Greetings, welcome to today's session where we will be looking at the integral of tan x cubed, which is integrated with respect to x for the given limits from 0 up to pi over 4. So if we zoom in into our integral, we have tan cubed x dx, which is evaluated between 0 and pi over 4. So the first thing which we should attempt to do is we have difficulties dealing with powers when we are integrating. So what I'm going to attempt to do is I'm going to leave this as tan x multiplied by tan squared x dx. So I'm trying to figure out how is tan x related to tan squared x. I look at tan x, I'm trying to figure how can I find tan squared x, tan squared x. And the answer is not so obvious how we can do so. So what I'm going to do is I'm going to remember that my tan squared x is the same as our sec squared x minus 1. So this might be useful because we know that tan is somehow related to sec. So let's go and rewrite that expression to be tan x. And the reason why we are saying tan is somehow related to sec, it is because the derivative of tan is equal to sec. So that is why it is useful for us to write the expression in terms of x. So let me make a note of that. It is useful to write the expression to have sec squared x because our derivative of our tan, which we have tan x, will simply give us sec squared x. So that's why what I'm going to do is wherever there was tan, I'm going to replace it with sec squared x minus 1 dx. This is evaluated between 0 and pi over 4. So if we look at what this becomes, we have 0 and pi over 4, we have tan x multiplied by sec squared x and then multiplied and then minus tan x dx. So when I look at this part here, I can tell that if I derive tan, I should somehow get sec. But however, since I still have the tan there, so you have two options here. You can either go and use U substitution, use U substitution, which I'm not going to go down that route. I am going to observe and work in reverse. And then the tan there, what I would like to do is I want to write that tan in terms of cosine and sine. So I'm going to write it as minus sine x over cos x dx. And then before I carry on, there's something which I want you to remember. If you do not remember, I want you to know that if we have the integral of f of x on the denominator and what appears on the numerator is the derivative of the denominator, the answer simply becomes ln of f of x plus c. So if I look at this here is cos x. When I derive, you will see that I get my numerator, which is negative sine x. And now when I look at the first part there, I know that it must have been tan, which I derived for me to get sec squared x. But since the tan is there, it must have been originally to the power of 2. But since I don't see the 2, by chain rule, I should just divide by a half or multiply by a half to undo the effect when we derive. And then for the other part, you will see that for the sine part, all what I will have is simply ln of cos x, then plus c, and this is evaluated between 0 and pi over 4. So I'm going to go ahead and substitute half tan squared of pi over 4, and then plus ln of cos of pi over 4, and then minus a half tan squared, we put in 0, and then minus ln of cos of 0. So if I may remind you, should remember that tan of 45, which is the same as pi over 4 in radians, is 1. And then cos of pi over 4, which is the same as 45 in degrees, it is 1 over square root of 2. And then tan of 0 is 0. And then ln of, and then cos of 0 is equal to 1. Then ln of 1 is 0. So if we have a look at what is going to happen, is our integral, which was the integral from 0 to pi over 4 of tan³ x dx, it will be equal to 1 over 2 multiplied by 1, then plus ln of pi over 4, which will end up being ln of 1 over square root 2, and then that will be minus 0, and ln of 1 will also be 0. So essentially our answer is simply a half, and then plus ln of 1 over the square root of 2. And we can find ways to rewrite this by simply remembering that the ln of a to the power of b is b ln of a. So if you think of what is happening, is we have ln of 1 over square root of 2, which can be written as ln of 2 to the negative a half, like that, which can easily go outside to give us a negative half ln of 2. So we can write our final expression like that. So our final answer can be left as tan³ x dx equals, we have that half minus another half ln of 2, like that.